In lesson 4.10, you will write quadratic functions and models. In this first example, we're going to write a quadratic function in vertex form for the parabola whose graph has vertex -2, 3 and passes through -4, -1. In this problem, since they give us the vertex, which is hk, and they give us a point, xy, we would want to use vertex form in order to write the equation of this quadratic function. And remember, vertex form looks like this: y equals a times the quantity x minus h squared plus k. Now they gave us everything in this equation except a, so that's what we need to find. So in for y we should put -1. We'll solve for a. In for x we should put -4. In for h, -2, so that's minus a -2. The quantity squared plus k, and our k value is 3. So now we can solve for a. Inside parentheses I'm going to simplify because I have -4 plus 2, which is -2. And that -2 squared is 4, so I have 4a plus 3 on the right hand side. Now I'll subtract that 3 from both sides, so I have a total of -4 on the left equals 4a, and dividing both sides by 4 I find that a equals -1. So now I can write my equation in vertex form. Y is equal to a, which is -1, times the quantity x minus h, and h is -2, so since that's double negatives, I'll write that as x plus 2, the quantity squared, plus k, and k is 3. Okay, in this example, we're going to write a quadratic function in standard form for the parabola whose graph passes through -2, 30, 1, 6, and 4, 36. To do this, we want to remember that standard form is y equals ax squared plus bx plus c. And using each of these points, x, y, we can write a system of 3 equations in 3 unknowns. Our 3 unknowns are going to be a, b, and c. So our first equation, in for y I could put 30. It's equal to a times x is -2 squared plus b times x, which is -2, plus c. The second equation, using the second point given, I'll put 6 in for y, and in for x I'm going to put 1. And then the third equation, 36 goes in for y, and 4 goes in for x. Now I'm going to clean up this system. That first equation, -2 squared is 4, so I have 4a minus 2b plus c equals 30. And the second equation, 1 squared is 1, so I have a plus b plus c equals 6. And the third equation, 4 squared is 16, so I have 16a plus 4b plus c equals 36. Now remember, a system of 3 equations and 3 unknowns, you can use substitution or elimination. I'm going to choose to use substitution on this system. So in this middle equation, I'm going to solve for c. c is equal to 6 minus a and minus b from the left-hand side. Okay, so now I'll substitute into the first equation for c, so that I have 4a minus 2b plus c, which is now 6 minus a minus b equals 30. And the third equation, I have 16a plus 4b plus c, which is now 6 minus a minus b, and that equals 36. Okay, so now I'm going to want to clean up these two equations in two unknowns so that I can solve for a and b. And I have 4a minus 1a, that's 3a. I have negative 2b minus 1b, that's negative 3b. And I'm going to subtract the 6 from both sides, so I have 30 minus 6, or 24. Okay, now adding like terms in the second equation, 16a and minus a is 15a. And 4b minus 1b is 3b. And subtracting that 6 again from both sides, I'm going to have 30 on the right-hand side. Okay, now in this system of two equations, two unknowns, I could use elimination because I see that if I add the two equations together, I'm going to eliminate my b terms. 3a plus 15a is 18a, and 24 plus 30 is 54. And now if I divide both sides by 18, I find out that a is equal to 3. 3 times 18 is 54. Okay, now that I know a is equal to 3, I'll go back to either equation in this system of two equations, two unknowns, to solve for b. I'll choose the first one. So I have 3 times a, which is now 3, minus 3b equals 24. And 3 times 3 is 9, minus 3b equals 24. So subtracting that 9 from both sides, I have negative 3b is equal to 15. And dividing both sides by negative 3, I find out that b is equal to negative 5. So now I know a and b, so I can go back to where I started, where I solved for c, and I can find my c value. So c is equal to 6 minus a, which is 3, minus b, which is negative 5. So solving for c, I've got 6 minus 3, that's 3, and 3 plus 5 is 8. So now I can write my equation in standard form because I know what a, b, and c are. So I have y equals a, which is 3, times x squared, plus b, which is negative 5, times x, plus c, which is 8. Okay, here we're going to write a quadratic function in intercept form for the parabola whose graph has x-intercepts negative 4 and 0 and passes through negative 3, negative 9 halves. So in this equation, or in this problem, since we're given the x-intercepts and a point on the equation or on the parabola, we would want to use intercept form. And remember, intercept form is y equals a times the quantity x minus p times the quantity x minus q. So they give us a p and a q value, those are our x-intercepts, and they give us a point xy. So again, we want to solve for a. So in for y, we're going to put negative 9 halves. We're going to solve for a. In for x, we're going to put negative 3. And in for p, negative 4. X again is negative 3. And q is 0. So simplifying on the right a bit, inside parentheses here, I'm going to have negative 3 plus 4. Well, that's 1. And here I have negative 3 minus 0, which is just negative 3. So multiplying on the right, I'm going to find out that I have negative 3a. And now to get just a, I need to divide both sides by negative 3, which is the same as multiplying by negative 1/3. So I'll multiply both sides of this equation by negative 1/3 to get a alone on the right. A is a negative times a negative is a positive. 3's cancel. So I'll get positive 3/2 for an a value. A is equal to 3/2. Now I can write my equation in intercept form. Y equals 3/2 times x minus p, and remember p was -4, so that's double negative, so I'll write that as x plus 4, times x, take away q, which is 0, so I'll just leave it as x. So just cleaning up this equation then, again, I'll write it as 3/2 x times the quantity x plus 4. Include with your notes of this video guided practice problems 2, 3, and 4 found on page 310 of your textbook.